Okay, welcome everyone to Robot Builders Night Virtual for Tuesday, December 3rd, 2024. And we're going to start with a little DPRG. Well, I was going to have some DPRG business, but I think we'll maybe wait till a few more Dallas people are on the line because it's centrally about that. Got one person in the queue, myself, and then we'll go to open mic. So with that, I have something to show that I'm quite excited about. And it's so I kind of like introduced it. I just discovered it last meeting and kind of shared it, called RoboRemo. So something intended as a easy way to, hopefully easy to, I found it to be pretty easy to communicate with robots, both sending them commands from a GUI on a cell phone and receiving status from a GUI on a cell phone. And so I've been not exactly busy, but a little bit busy this week, exploring it. I bought the full-blown package, and it's so what it has is so I think it's roboremo.app is the URL. Let me just check that. Yeah, that's it. So let me plug that into the chat.
Does it allow you to look at different sensors in the phone, the camera, GPS coordinates, that kind of stuff? Or
no, it's nothing. It's nothing to do with that. What it is it's a Android app, no iPhone, but we're geeks, we don't use iPhones. That it's an Android app that contains a GUI builder and comms, Bluetooth, network or networking or serial, that you talk to something on your robot. It comes with lots of Arduino examples. So I'm going to, I think, just share a sketch here. And well, actually, let me demo it first. And so I'm going to kind of do this. Okay, so there's an example interface, and this is
slider.
Yeah, I put a couple of sliders there. There's a whole range of things there. Oops. So hopefully you're seeing L 0.11000, lots of zeros. So if I just change the slider here.
You need that third hand there, I think.
I do. It's not picking up.
There you go.
Yellow too well, and it changed to L 0.4 minus 0.4, and I slide it off of it. L 1.0. So this is sending a slider command from the cell phone to, this is an ESP32 device running Arduino. Looks to me from the code that it could run anything that it's not specific to Arduino. You just want to have, a startup function that initializes your comms, and then a loop function that fishes data out of the whatever comms channel you're using. So as far as comms channels, let's see, you've got disconnect, so we can disconnect, and
so is it Bluetooth?
well, I'm using Bluetooth at the moment, but I have also tried it with UDP on networking, and it can work on TCP with networking and serial and USB.
Oh, cool.
I'm not quite sure if it's USB serial or what. So when you press connect, does it say connect? No, that says disconnect.
Disconnect, yeah.
Oops. Okay. It's sort of difficult to do this backwards. Try this. Okay, so I just pressed connect, and it's offering for me to connect to. Boy, it just won't focus properly, will it?
There you go.
Yeah, to connect to Bluetooth via RF comm, which is Bluetooth serial, or Bluetooth BLE, or Internet TCP, or Internet. I don't know what that next one means, or Internet UDP, or can't read the bottom one.
USB serial.
serial.
Oh, okay. Yeah. So, what I'm really seeing this as is, well, maybe that'll work better. Is a way to get something hooked up to your phone, to your robot, with absolutely minimal configuration. So
yeah, kind of a replacement for Ray's Geek Magnet.
Yeah, and John's Ray's Chick Magnet and John's watch.
Yeah.
But something that doesn't require GUI programming. So if I've got M5 RoboRemo here is a Bluetooth device that I've previously paired. So that's all you need, is to have paired it. And you press that, it goes to connect. And now this is connected to the device, and you can push the sliders. Oops. That went to something that I didn't mean it to. So this is linear. This is intended to be linear. Okay, what mode am I in?
Looks like you're connected.
Yeah.
Yeah.
Okay. Oh, I'm in the editor mode. So you can change the editor on the fly while you're connected. So I'll exit the editor here. Oops, I'm seeing it backwards, so it's kind of hard to make out what it says, but I'll exit the editor. And now, with the exited editor, I should be able to. So what was happening? And there we go. We have a different reading on the device. What was happening just then? So you configure the GUI with this edit UI menu, and if you press anywhere on a blank screen, oops, you get a list of things that you can add. So buttons, slider, a joystick, a level scrolling, which is like a level bar. So the significance of this screen is that you create your GUI on the phone. No need for GUI programming and graphic libraries and menus and all that entails.
Oh, so it's bi-directional, it looks like.
It is bi-directional, so you can have a log item. So I'm going to just change now to, I'm going to add a text log, and you drag it with you drag it with your finger. You can resize it with the bottom right and move it around with the top left. And now that's a text window that can receive stuff from the Arduino. So now I'm going to plug it into a serial port, into the serial port on my PC, and share out.
So what did you plug into the serial port? And did you plug in your phone or the receiving end, or?
So it's just USB
Oh.
that you program any Arduino with, or in this case,
Yep.
the ESP32. And I'm going to, so you might want to keep me pinned, but I'm going to share
Your screen.
This window, and let's see, is that coming? Can you guys read that, or is it too small?
It's a little small.
It's an older crowd. You got to go with the bigger text, Just kidding.
No, he's not.
Yeah, he's not kidding.
Please make it bigger.
See if this works any better.
Yep.
There we go.
Aha.
Okay. So the heart of the thing is, here's where you define the device name, M5 RoboRemo. So that's the Bluetooth name that you connect to on your cell phone. And then there's a buffer for the serial characters coming in from RoboRemo. Setup initializes the LCD on this little device, sets a cursor, prints the device name. So now I'm going to, okay, so now when it starts up, let's see, let me connect this serial port. Why am I not connected? Am I connected? I want this thing. There we go. Oops. There we go. Okay, so now if I touch something on the screen, you exit the editor. Okay, and then what I want to show here. Okay, so just running through the code real quick. Does serial begin and serial Bluetooth begin? Print something out to serial. If a new line terminates a command from the phone, so then it just prints the command. And then in loop, this one just sets the text size, checks if serial has anything available, and if it does, writes it to Bluetooth. Checks if Bluetooth has anything available, and if it does, it puts it in the command buffer. And if it gets a new line, then it calls exec command, which just simply prints it. So pretty simple stuff. But what I want to show here is the this text button, and simultaneously I'm going to type some stuff in here. Okay, it'll come through when I hit enter. Hello, in V, and enter, and there it is. It's pretty small, but in fact you almost can't read it. But anyway, so that's an example of sending data back to a text log, and there are other widgets that take data back from the Arduino, like the slider. So that's the let's see if there's anything else. You can import and export your GUI designs, and you select different GUIs by going to, they call them interfaces in this thing. So an interface is a GUI design, and so if you hit select, you get a menu of can't read that. Oh, sliders, cheap Wi-Fi, RC car, and another sliders. So the cheap Wi-Fi RC car is this, which works better this way. And if I press one of these buttons, you should see the output on the serial monitor. So it's in F and S. So when that's forward and then stop. So if I press the button while I'm pressing, it sends an F, and then when I release, it sends an S for stop. So that's just how they've programmed the button, but there's options in the button programming. If I go to editing this UI and press one of these buttons, then that wasn't what I wanted. Okay, so no, that wasn't what I wanted either. Let me just, so this is I just touched the gray part with that has the arrow image superimposed on it is the actual button. And so these are the parameters that you can put on a button. It's text size, but most importantly, what the action does, whether it's sent remote or it does something local. I'm not sure what that means, but there's a repeat button here, and you can set the repeat rate. And yeah, I think that's it. So anyway, point is you got similar, fairly flexible capabilities for these widgets. So I think of them as widgets, and there's 19 of them, and the widgets are button, slider, joystick, LED, which would be coming back from the robot, level indicator, text log, accelerometer. Not quite sure what that does. The text field, which is what we looked at, that blue log thing that printed the text coming back from the device. Plot, so you can plot like whatever you want to plot coming back, and somehow you put a if you add a plot, or if you add these input widgets, you put a header on your, or you put a preamble in front of your message that says what widget it's supposed to go to, and then you put a corresponding, as I understand it, or I assume, I haven't actually tried that, put a corresponding filter, if you will, in the widget to only accept messages which are text strings followed by a new line, and that directs your data coming back from the robot to a particular widget. So you might want to plot acceleration or steering, for example, or speed or steering or some such. And so that's what the plot would let you do. You can put an image, which you can set as a background, so have a picture of your robot. A touchpad, I'm not sure what that is. Keyboard connector, not sure what that is. It's got a heartbeat sender, which will send periodic pulses from the cell phone to the Arduino. The idea is you can use that for a dead man timer. So if your cell phone app crashes or you get disconnected, then your robot knows it's no longer in contact and it should stop.
Get too far away from it or something.
Yeah, right. There's a touch stopper, so it kind of uses the I know it'll send your touch to the nearest control unless you surround it with a touch stopper, but many of the controls let you say only respond to an exact hit. So I don't know why they got that, really. The file sender and a receiver, a speaker, and a printf. So anyway,
That is really cool.
Yeah, it's pretty flexible. So I was like real excited about that. So I plunked down for $10. It's not bad.
So can you save different GUI files and load them?
Yes, there's an import and export function which I've used and it works, and that exports what they call an interface to an interface file, or imports one. Haven't quite figured out how to get the imports up onto that selection. Like when you import something, it's there, but I'm not sure it's really on the menu of. So this is I haven't played with it a whole lot. Doug kind of challenged me last week. He said, "Oh, I bet maybe you should put it on Mobot," and so I'd like to, but I haven't gotten that far yet. So let's see what else. I think that's all I had to share. Let's see. I'm sorry, I forgot Z2231's name. Bruce, I think.
He's asking what Mobot is.
Oh, Mobot is my robot. It's my lawn mowing robot. Sitting down there. It's an old friendly robotics lawnmower. So I guess the other thing that is worth mentioning maybe is where you'd fit it in, where I see fitting it in to the architecture. So let me just pull up Mobot's webpage and go down and share out the block diagram. Let's see, there, no, that one, share, and we'll go to that. Can you guys see this block diagram? Or is it too
Yes.
small?
A little small, but
Let me drag it over here.
Yeah, we lost the block diagram. We've got a ring alarm now.
Oh, okay. Yes, that would be right, because I detached the tab. Let me reshare that window. There we go.
There it is.
So I see this, of course, it's a general problem with robots that you need a teleop device to walk it over to or to have it drive it over to a contest start point or back to the pits or whatever. And so, and one of the things that's real nice about Ray's display chick magnet and about John's watch is they're almost zero setup. You just turn them on and they hook up. And I see this as being kind of similar in as much as you just have to connect to Bluetooth, a Bluetooth that you've previously paired. And then I would see it hooking up to the ESP32 Arduino. So we've got the Raspberry Pi 4 up at running the autonomy, path planning and obstacle avoidance and high-level software. You got an ESP32 Arduino accepting encoders and sending motor commands, so doing low-level machine control stuff. And I would see this thing turning on its Bluetooth, which, so I just demonstrated an ESP32 turning on Bluetooth and accepting commands from your cell phone. So I would see the cell phone talking directly into here and sending in teleop messages, and then this thing can say, oh, I got a message from the cell phone that should override everything, and let you directly drive it without having to depend on the autonomy software running or networking going, or there's like just a host of dependencies to get autonomy layer over TCP, like talking and running. And the idea of this, or the way I see, one way you could use this is as a almost can't fail if you're right there by it within Bluetooth range. You're like always active. You open up Bluetooth whenever the microcontroller starts, and it's just sitting there waiting for a cell phone to connect to it and send it motion commands, or whatever might be appropriate. You could also have the turn on Bluetooth in the Raspberry Pi, and they do say that you can that will work. They have some example code for Raspberry Pi that turns on its Bluetooth. On the ESP32, I was using the built-in Bluetooth, but they say that they support BlueSmurf connected to an Arduino. So for people who are using a real Arduino and can fit a BlueSmurf, what do you call them, shield on it, that's how you could get your commands from Bluetooth from the phone into your Arduino code. So let's see. I think that's, let's see, is there a way to change your display meeting while you're in the meeting? I don't think so, Bruce. It's something you would do before you log on. And as far as I know, maybe someone else knows different. Okay, anyway, that's what I had. So since we don't have anyone else in the queue, and check if Doug joined. No. Okay, so I'll hold that item. Let's move to open mic, and anyone who's got questions, stump the club.
I got some.
Oh, go ahead.
I'm going to show a little picture first if I can find it here. Window. This one. Okay. Let's put that up. I assume you can see that. Oh, actually, that's not the right picture. Let's close that again and try again. Too many things open at the wrong time.
But that looked like an interesting picture.
Well, it's gonna be fun. How come that window is not showing? It's right here. Ah, that's not it. That's not it. Well, let me try again. The window, I can see the window sitting here and I can't share it. It's not appearing in the share list. Oh yeah, there it is. Got it. Okay, let's see if that's any better. This is actually a printout of the earlier spreadsheet graph with some annotations on it. First, a little bit of background. I've been slowly learning more about the capabilities of the GPS I've got on my robot and the conditions under which I'm attempting to use it. Having been mildly frustrated at times, and of course being very ignorant of how GPS really works. So I've been learning a lot. That's derived me a few questions, and as I learn more about things like dispersion, I realized that's probably a very effective measure. This is a dispersion graph of the GPS coordinates of the GPS unit, which is a Neo M6, sitting on my robot, sitting out in the road last week with some additional logic in it to allow me to capture the GPS information and some other stuff over the course of several minutes, sampling about once a minute. Now, on my robot, I take the GPS coordinates that I get from the GPS receiver, and I subtract them from a local origin, a local GPS origin, in order to give me relative numbers. And that's what's graphed here, is basically the X and Y coordinates that the GPS is reading, or that the robot is reading second by second, compared to the GPS origin data, which had been taken at a previous point in time that same afternoon, but in the same neighborhood. The local origin doesn't have to be in exactly the same place. That's not important. The units which are on this graph are in centimeters. So just divide them by 100 and you'll get meters. At the time of the test, I had 6 satellites being used by the GPS receiver. They're all American GPS satellites, because that's all a 6M is capable of. The horizontal dispersion of precision was 1.7 for the whole test, and there's about 120 data points here. The horizon at the point where I did the test is not great because of the neighborhood I live in. So to the south, the horizon starts at about 45 degrees, because I basically live at the foot of a hill to the south. So the hill kinds of blocks stuff and my house blocks stuff. In the other directions, the horizon is about 15 degrees to the south and 10 degrees to the east and west. So I don't see all of the satellites that might otherwise be available. At the same time, when I use a GNSS receiver on my phone with some test software on it to see what else might be there if I had a more modern receiver, I will see a couple more GPS satellites which are not strong enough to be used. And I will see 2 or 3 Russian satellites, one of which would be strong enough to be received and the others are not. Those are all the satellites that are visible on a GNSS receiver running some test software. So the fact that I'm running a 6M, which can only see American GPS satellites, doesn't seem to me to be a big issue. I would previously have said that I've probably got about the best conditions I can get for operations. I've got 6 satellites, I've got a 1.7 DOP, and I'm collecting data. And then I plotted this stuff. So first of all, the watching this or examining the dispersion, the first data in the set is up here. And then as you look at the progression over
before you go forward,
Go ahead.
I'm assuming that this is a stationary test.
It is a stationary test. Yes.
Okay.
Thank you for the clarification. That's what starts to get a little frustrating.
And
So
do you know where the true position is in that?
I do, but for purposes of my discussion, it's not really important.
Okay.
Doesn't matter, yeah.
So as I plotted this stuff and I looked at how it progressed over time, that's why I left the join. This is an XY scatter graph, and I left the lines in between them simply because it helps trace out the path over time. Where's my mouse? So I assume you can, oh, that's not much of a dot. I assume you can see that moving.
We can't see the mouse.
Okay. The upper center is where the dots begin, and the dots then progress downwards and to the right on my screen. They hang around a little bit in the center. Then they go out here to the left, which is over to the east. And there's about 40 or 50 samples that are over here, and they slowly move around. Then they hover around the middle here a little bit. Then they wander down here to the bottom right. Then they come back up here. So that this isn't exactly what you would call a random distribution. This is clearly an interesting phenomena that is causing the dispersion of the measurements. So this gives me, over this 2.5 minute sample, roughly a dispersion range of 3 meters horizontally or east to west, and about 4 meters if you include everything in the north to south direction. My guess, my feeling is this is probably about as good as I can get under the circumstances that I'm testing in. So that leads me to start to ask some questions about how to make it better. One of the things that I discovered in my research is, of course, that this system is using the L1AC GPS signals. The L2C signals are available, but you need a significantly different receiver in order to accept them. And if you can receive them together with L1, you can apparently get more precision in GPS measurements. Although I could not find any statement about how much better. So my first question is, are any of you using a GPS receiver that's L2 capable? And have you noticed any improvement in accuracy?
Everyone who's using the F9P has L1 and L2. Probably Ray's got it as well, right, Ray?
Yes, so.
Yeah.
Yeah, on the AP. So I would say that there's a lot of confusion about that out there. Again, I don't consider myself an expert on this, but I've delved into it, and I would say that the original indications I got was, yeah, you're going to get better accuracy, but the real truth is you're getting better reliability.
Yeah.
What you are getting in terms of accuracy is a little bit better when you're near structures, but it's not going to improve you like, but again, that's really more about preventing dropout as much of signals. So your signal quality does go up a little bit, but you're still going to get this random walk behavior.
That's what I thought. Yeah.
Yeah. And it's going to be, it might be a little bit tighter, but it varies a lot depending on the environment you're in. And so it's more about, but you will definitely get more satellites.
Yeah. Kareem, I was headed towards that solution as well from my reading, is that you get a few benefits. You get the ability to perhaps establish a little bit of what the atmospheric distortion is, because you're at 2 different frequency levels, but not much else apparently.
Well, the other thing that I get from my understanding is much faster startup.
Yes.
And particularly if you're or much faster convergence on a fix is perhaps a better way to
express
it. And it was particularly noticeable when I had a RTK set up back in the 2010 or 2012 timeframe, and it would take it only had L1, and to get an RTK fix you took about 5 minutes, versus with L1 and L2 you get an RTK fix probably inside of 30 seconds.
Okay. So the next question I have is, I am using the stock antenna that comes with a 6M when you buy it from U-Blox or its distributor. I note that there are other antennas. I see most of you using other antennas. I see some discussion of other antennas, and I see some discussion of ground planes to mount the antenna on, including a very excellent white paper by U-Blox about antenna grounding. Basically the ground plate that you sit the antenna on.
Mhm.
I do not have any of those ground plates. My antenna happens to sit on a little metal plate that's not much bigger than the antenna, but that's not really much of a ground plane for purposes of preventing the backscatter interference, as I understand it. What I don't know is, would it make sense for me to get some form of better antenna and or some form of ground plane to put my existing antenna on? I know nothing about these antennas. They don't appear to be passive, but I do not know if they have the low noise amplifiers or other things built into the antenna module instead of the GPS receiver module. I simply don't know. Any thoughts on antennas?
Antennas are, yeah, I mean, it's worth investing in a good antenna. It's worth having a good ground plane, although the ground plane doesn't really matter. I've made mine out of a pie tin on one of my robots, and it worked just fine. The ones that you get that ship with the F9P kits, which is an L1, L2 antenna, those are thick metal plates, about 4 inches in diameter. The main reason that they're heavy metal plates is because it's a magnet mount capable. The antenna is a magnetic mount, so you can also like just toss it on top of your car or on top of your excavator. And
Curious enough, U-Blox said they made them thick so that you could put a tripod mounting screw through them without coming out the other side.
that also, right? But yeah, and you can get them with proper tripod mounting screws built in. But quite honestly, an aluminum pie plate, a throwaway pie plate, works for the purpose of a ground plane.
Okay.
It just needs to be conductive.
Yeah.
And it definitely needs to go outside of the boundary of the antenna's dimensions.
Of course.
But I don't know that you can't just stick an L1, L2 antenna on a receiver that only receives L1.
I didn't think so, and I'm not sure I don't see or read any technical discussion of an antenna that would be suitable for the receiver I've got.
Yeah, those normally come integrated, don't they?
Well, they're separated by about 3 inches of cable.
Oh, really?
Yeah.
Are you sure your receiver is only L1 and not L1, L2? Because nearly all of them are L1, L2.
This is a 6.
The 6 is definitely L1 only.
Okay.
And in fact, you have to get up to the 9s and only some of the 9 models before U-Blox data sheets mention that they're L2 capable.
Really? Wow.
Yeah, not all of the 9s are L2 capable as far as I can tell.
Huh.
Yeah, it's not necessarily all of them.
Oh, really?
You have to be
Yeah, I
careful.
just asked Copilot about the Neo M8P, and it said it supports L1 and it does not support L2.
Right.
Huh. I didn't know that.
Yeah, then they have a lot of models. I had no idea how many minor variants on each major model there was. There's a lot.
Yeah, we keep there's a tendency to assume that the 9 series means capability, but it's not. It's just a generation of their silicon, basically, and within it they have so many different models and submarkets that they're targeting.
in addition to the ground plane, the other reason I was looking at a replacement antenna was because presumably an active antenna might have some gain in it where the unit that comes included with the 6M does not have any gain. It's just I thought it was just a passive one, but I really don't know. There isn't much information on what's inside, and I haven't taken one apart yet.
Yeah, I think the F9s actually have a powered antenna, don't they?
Well, they're powered through the coax cable.
Yes.
Right.
Right.
Yeah.
So the antennas do draw power.
Yes.
Yep.
But they are active. But yeah.
Yeah.
And if you don't supply enough power to your module, you'll sort of be sadly out of luck. That's basically the failure mode for my so I've had 2 of the F9P boards go bad on me
Ouch.
over time.
Ouch.
Yeah, it hurts. It hurts
Yeah.
replacing those.
Yeah.
And in both cases, it was the antenna power side that was failing, and all of a sudden it just couldn't pick up satellites.
And
Wow.
I have one of my 6Ms that's failed that way. The module itself that does the computations works fine, but
Yep.
the antenna doesn't work anymore.
Yep.
Mhm. Actually, I remember something they used to have in some of the cell phone parts, a low noise amplifier, LNA, and I think that's what's powered in the antennas that actually receive a DC voltage.
Right. So you're saying it's probably an active antenna that I have. And in that case, substituting any plain Jane antenna off of the AliExpress shelf is not a good idea, since I have no idea what it will be.
Yep. In fact, I think, I know SparkFun recommended certain antennas, and
Yeah.
they were the most expensive antennas that SparkFun sold at the time.
Okay.
Of course.
So I can probably do something with a ground plane that might be worth experimenting, but I probably can't do anything with an antenna without a lot more knowledge. Let me ask the next question. And
Well, before you move on though,
Yep.
Something on the ground plane. I didn't know or think that ground planes were that important for just regular GPS. They're absolutely crucial.
But Paul, read the U-Blocks white paper on ground plane.
Okay,
It's an
Okay.
eye-opener, I'll tell you.
really?
They will always help.
Oh, because you don't have one in a cell phone, right?
Which means they don't work very well.
In a cell phone, you have they've got pretty good fusion with other signals from like Wi-Fi and that kind of
Okay.
stuff.
Cell phone towers.
That they can stabilize. Yeah.
Yeah.
But if you're using RTK, a ground plane is absolutely mandatory, because what it does is prevents the reflection off of the ground from coming back up and hitting the antenna, this much or whatever the antenna height is later than the direct signal.
Yeah, but that's true for any GPS receiver. It's still going to add more noise, right? And timing. What you basically get from ground bounce is a timing fluctuation as well.
Right.
So a ground plane's always going to help. It's not going to be that obvious that it's helping in something where you've already got a 3 meter spread.
Yeah.
Right. So you may not know, you may simply just notice it more, but I've also got 2 centimeter accuracy without a ground plane on RTK. It's completely possible. It's just better to isolate yourself from those variants.
I just put the link to that white paper in the chat.
Thanks. And did you say these coordinates, XY coordinates, are in centimeters?
Correct.
So then at the very beginning of the plot, we see about 40 centimeters, maybe 30 centimeters between successive 1 second samples. Is that the way to read that?
I think so.
Because this bears on the discussion we had last week about using GPS as a compass, and whether, I expected and had hoped to actually do this experiment. And I'm really glad you did, Tom. Thank you. To show the wandering, the sort of like serial wandering nature of the readings. But what I didn't have a sense for was the magnitude of how much it would wander in a second. And what you're saying is it'll wander, it can wander as much as 30 centimeters.
Yes.
But the wandering rate doesn't matter, Paul. Not really.
Why not? If you try to use it as a compass?
Because you don't really. So in other words, I wouldn't rely on the wandering rate to narrow down my belief in where my ground truth of where I actually am.
No,
Right.
not
I would do the whole spread. Right. Well, you got to know from where you are is how you determine your angles, right?
Sure, but I'm talking about knowing what direction you're headed in, what direction the robot is headed in.
I know. Yeah. But you may have had a faulty belief when you started about where the robot is headed in. So that's why I would sort of take. I would be aware of the full extent of this wandering, right? And that would set the accuracy that I'm going to I'm going to believe exists in any reading that I have. So what I'm saying is, in this case, if I want a certain degree of, like, I don't know, I'm just guessing off the top of my head, I want to be within 10 degrees of certainty, and I see that there's a 3 meter radius of uncertainty around where I actually am from versus what it's actually telling me, then I might want to be 50 meters away from this original location, through odometry, before I say I'm far enough away to believe the angle difference between those two locations.
Yeah, I understand what you're saying, Kareem, but I don't think you're quite getting the point that I'm making. Oh
no, I understand your point. I'm just disagreeing in the modality of it. I know what you're saying, that short range of time, your reading just changes a little bit, and therefore, if you're also driving, you would expect the wandering component of that to have moved just a very little bit.
Yes.
I completely understand your rationale, and you may actually be right. I'm saying I wouldn't trust that, like in a high risk situation. Like
sure.
If we were talking about driving cars or something like that.
Fundamental assertion that if it doesn't wander much between successive readings, then it could be reasonable to take your direction of motion from 2 successive readings.
Yes, except that these tests are always done when you want to find out how much wandering is happening. These tests are typically done when your robot is stationary. So I don't know that the wandering would look like that while it was moving.
Paul, the real question is, how far does your robot go in 1 second relative to this potential error?
Right. And the magnitude of that 30 centimeter jump between 1 second readings gives me pause. What would be really good would be to ground truth this with an RTK reading.
That would be interesting.
So while the robot is in motion, because my understanding of what causes this wandering is that the troposphere or the ionosphere is moving around, and it goes up and down, and its propagation delay changes because the signal path kind of like wanders around, but it does so because it's up in the atmosphere where things don't move like tremendously quickly, and that's what causes this wandering.
Yeah, that's right.
And so the fact that it sort of wanders in a serial manner, in a step-by-step following a path, is not surprising.
Yes, it was extremely interesting stuff to know about. Of course, my takeaway was that 3 meter by 4 meter error range in only 2.25 minutes. Next question. And as much as I hate to...
Can I follow on with one
Go ahead,
further,
Paul.
just clarification, Tom? I think you said h-stop. I thought you expressed that it was in meters, and I just want to clarify that it's not. Horizontal dilution of precision, as according to my understanding, is a ratio of the variance. So you would expect the variance of the measurements to be 1.7 times greater than the antenna is telling you it is. And that's due to the configuration of the satellites in the sky.
Okay, that I cannot comment on because I don't understand the math of computing dispersion of precision. The HDOP is the one that's provided by default from the U-Blocks receiver, and I haven't changed that. I know the other HDOP measurements are there. There's the vertical and there's something else, the P-stop, I think. But I haven't looked at those. So I only used the one that came out by default, which seems to make sense because I'm only interested in accuracy in the horizontal dimension.
Yeah,
I
Tom,
just wanted to clarify that not in meters.
yeah, and you keep saying dispersion, but it's actually dilution of precision.
I'm sorry.
I don't know if that matters, but you know.
Thank you for the clarification.
Sure.
I have a hell of a time remembering either one of them.
I have one more comment on getting heading from GPS. A while back, I read a blog post of someone who put 2 GPS receivers on the ground, 1 meter apart, one north of the other, and measured that drift. And it was a similar thing where it drifted, the angle drifted back and forth slowly. So,
but did they drift together?
What's that?
Did they drift together?
Yeah, they mostly drifted but so he was measuring the angle. So he knew they were north-south, but he was measuring the 2 points and trying to get an angle and finding they drifted a few degrees back and forth over several minutes. And it was a while back. I don't remember what the exact numbers were.
Interesting.
But his point was he decided he couldn't really get a reliable heading. Something like just a gyro compass worked a lot better.
Yeah, but over large distances of movement, you can get an average heading change that's pretty accurate. It just how much different distance you have to travel is related to how precise your signal is.
Right. And putting 2 GPSs on one robot that are separated by less than a meter wasn't sufficient, at least for him.
Well, they do that on tractors all the time, but those are typically RTK units, so they'll put 2 on a full-size combine, and they'll get rock solid headings and travel and everything that way.
This was several years ago, and it wasn't RTK.
Right.
But even several years ago, there's also satellite-based augmentation systems, SBAS, where they broadcast corrections from base stations over a satellite. That was a technology that we used on the self-driving trucks, and that can get you down to 10 centimeters of accuracy. So just because it wasn't RTK doesn't mean it wasn't augmented to pretty decent accuracy.
Mm-hmm.
Okay, we keep on cutting Tom off.
Yeah.
Don't worry. This is all good conversations because those are also points I need to get to in terms of being able to do better navigation. So the next step I looked at was, all right, am I going to have to bite the big bullet and go to RTK? So I took a look at what base station organizations are available where I live. There are 5 of them documented in a government organization called CanMet, which supposedly knows about them all. There are 3 of those organizations with base stations within a reasonable distance of my location. 20 kilometers, I understand, is the outer limit. All three of them are subscription-based commercial organizations. So I have not looked at what their costs are. None of them post their costs on their website. So I haven't looked into it because it might be pricey. But I am curious, and a couple of more questions come out.
You mean Pinkville Comedy Canada doesn't subsidize your your corrections?
No, probably not.
It's not government
Maybe I can
provided.
convince them I'm a researcher or something. There's got to be a free one somewhere, or some.
There are
subsidized one.
states in America that provide free correction services.
Yes,
Yeah.
I looked at the Spark Fund, some of the Spark Fund educational stuff, and they immediately talk about the free ones, but not in Canada.
Right in Colorado where
Yep,
they are. Yeah.
yep. I thought that
Okay,
was pretty cool.
this is Bruce. I dialed in. Can you hear me?
Yes.
Yeah, you can.
Yes.
Okay, so the I watched the YouTube video when I could have sourced some gentleman. He built an RTK2 Go, well, however, a receiver, one for his bot and then one for a base station, and spent less than $600. Does that
Yes.
sound
Yes,
reasonable?
you can do that. Yes.
Yeah.
Because I'm assuming that I'm going to have to build a base station, and I'm just planning on the base station being significantly less than $500.
So,
And
Steve,
Tom Latz.
Steve Edwards, our treasurer, built an RTK to go base station, which he made available. He's actually published it on RTK to go. So we used it. We could use it in the competition, and you could do that, Tom.
Yes, and I was starting to look at that, and one of the questions I had was, is it sufficient to go differential GPS with only L1 signals, or do you need to go to level 2, L2?
Every
You gotta have
RTK
it-
selection is going to have both.
That's what I was afraid of. Yeah, okay.
Well, no, you can't.
Excuse me. Hello. Excuse me. I think Bruce had a question and it wasn't quite fully answered.
It wasn't.
Okay,
We
Jim,
can't
what
give
did
you
you think
both.
my question? Okay, Jim, what did you think my question was?
Well, having to set up an RTK station of yourself and dish out all that money.
Well, he asked if it could be done for under a certain amount, and the answer was yes.
600?
Okay.
Probably just
Yeah,
barely.
but that's a short answer. Is there a bit of a longer answer to that?
Sure. You can use the exact same type of receiver for both the rover and the base station, and it gives you some failover redundancy, especially if you end up getting another base station that's in the area and you can pick up. Then you might have a second one for your robot or a spare when your antenna dies. So it's common to use two F9Ps for that kind of situation. And if you do happen to have a correction source, then you can wait on the base station, and you can get started with just the one for the robot. The pricing the other day was like $200 for it's like the lowest price I've seen for an F9P. That I don't know if that was a pre-Black Friday 1 week sale that they had, so I haven't
Who's
been there. This was at SparkFun
Oh,
a couple weeks ago.
Okay, thank you for clarifying that. I appreciate it. Thank
Yeah.
you, guys.
Sure.
When I
sure.
did some research on F9Ps, the price range I was finding was between about $150 and $225. So yeah, it's in that ballpark for sure.
but not for a complete solution, right?
With them if you need to do your own thing.
Well, you still gotta buy the you gotta buy the antennas as well,
Yeah,
Mm.
yeah, good point.
and that's a good chunk of change.
That might be another
What,
$30.
$90 these days?
How much?
Yeah, the
Maybe
things-
90?
Whoa. Okay.
something like that. And if you're gonna do a base station, you actually want one of the survey grade antennas. They have their built-in ground plane, and they're slightly nicer.
And how much might something like that be?
I think it's 120 last time I looked at SparkFun.
That's
120,
doable.
115.
They're commonly available on the side of highways.
They're they're a bit pricey for. I mean, they're a bit heavy for putting on most robots, but that's the kind you would see on a large tractor.
Their price is highly variable, Pat, depending whether you get caught or not.
Yeah, that can be very costly. Years.
Let me
Not in
just check my
Canada.
list here.
You show up at a court date and they tell you the jail's overcrowded and don't get into any more trouble.
Folks, that's all my questions on GPS. Thank you very much. That's added some clarification. I will clearly have to work harder at building my cone camera.
Pat, why,
Great.
why does that sound like the voice of experience, Pat?
I can neither confirm nor deny anything.
Great discussion, and thank you for that data, Tom. That was a tremendous,
Yeah.
fantastic graph.
I first learned about those from the U-Center tool because they have a nice circular one. And that's when it became clear to me that the dispersion graph tells you so much in a very simple form. I figured I better write my own because I can't take the U-Center out to the street. But I can gather my own data pretty easily on my MicroPython unit. Yes, it's quite interesting. I'm going to stop pretending my GPS is any more accurate than that.
It's not.
It's not.
But I value that graph for what it told me about the magnitude of jumps that you saw in 1 second intervals. That's a lot larger than I would have guessed, but it was only a guess.
And it's a trivial thing to build. It's just a couple of lines of JSON code that you stick into your existing robot logic in with a kind of a push button to activate the test mode. And that's all I did. And then when I bring it back in the house, I download the file.
Well, I just checked the RTK to go map, and there are no RTK to go stations up where you guys are. So this is your opportunity to make the first one.
Is that an American thing, or is it North
No,
American?
It's Indian. It's all over Europe and Africa.
Yeah, I'm in Iowa, and I don't think there's any base stations. I'm in central Iowa. I think there's one at the very edge of the state, but no.
So have you guys seen this graph? Let's see. These are all the pinpoints where there are base station, where there are RTK to go base stations. So you see a whole cluster around Europe, some around, a whole bunch around in Japan, and where's this? This is not sure, Vietnam, Thailand. Obviously, the United States is rich with them. And are you guys seeing what I'm sharing?
Yes.
Legible enough?
It is so weird that you don't see any in Spain or France.
On the one side you don't, but on the other side you do. It looks like.
Oh, okay. That's just a
Oh,
cutoff
yeah.
on their
Well, how
graph.
about that? But once you drill
There
in
you go.
and you can
This
have
was
a
not
look
for the
at
French, I guess. You know.
where's
So I see a couple of them in Southern Ontario. Just at the
To the
left
right.
end of Lake Ontario.
None where I am.
and where's Idaho? Idaho's out here, right? Yeah.
Is there Billings,
Okay.
Illinois? Don't know what it is.
Oh, it is Montana. So anyway,
Idaho's to the west.
oh yeah, got it.
It's kind of weird that Dallas has a really good cluster right now.
Yeah. And IMBA 1 is Steve's one.
I use the Kubota and the VN1 in Richardson.
Yeah.
They both work for me.
Where's Kubota? Oh, down there. Okay.
Kubota Central, yeah.
I've used VN1, and I live up here in Little Elm, and I've used IMBA 1, and I did run across a gotcha to be aware of that RTK GPS doesn't give you an absolute fix or absolute position. It gives you a position relative to the base station, which is then expressed in lat long. But I switched between VN1 and IMBA 1, and the same point in the ground ended up 0.8 meters away from depending on which base station I was using, even though I had 1.2 centimeters of accuracy.
Yep.
So just be aware that
you're relying on the accuracy of the base station's understanding of where it is and how well it's been calibrated.
Exactly.
Because it's just relative to that and versus what they publish.
So that made me crazy. I was having Wi-Fi and networking issues, and I thought, well, maybe VN1 is going up and down because they are a little unstable. So I switched over to IMBA 1, and all of a sudden my robot was going to a different place by about 0.8 meters. And I was like, what? And it took me a little while to figure out what had caused that. And I switched it back, and then it came right back in.
I would assume that Steve hadn't spent as much time, doing surveying and getting really accurate on his location.
Well, the standard
because his goes up and down. The VN1's been there for a long time, but I don't. Again, I can't. That's the whole thing. Is like I can't ever vouch for the 100% the accuracy unless you've taken a particular base station and measured your location against a known known and published location, that surveyed location.
Yeah, but that's not what they do. They turn it on for 24 hours and then average the fix over 24 hours. And there's I don't know of any way that you could assert that over 24 hours the scatter plot that Tom showed would actually be centered on your true GPS location. The assertion is that it is, but and that's the basis for what they declare to be the location of the base station. But can you vouch for? Can you really count on that?
Yeah, when I got the survey done on our new house, I had them plant a spike on a known location that they surveyed into within 2 inches. They didn't say centimeters. They said within 2 inches of accuracy.
Nice.
So I can use that when I set up my base station as an offset.
That's good to know.
There is tectonic plate movement, I don't know. I think
that's right. Everything moves.
US
everything in the universe moves. Yeah.
I actually have 2 surveyor's stakes on my property from eons ago when the area I live in was surveyed, but exactly where they are is never to be known. I know where the stakes are, but I don't know what they mean.
It's okay. I had a stake. The way the property that, where I live right now sits on, it was like a 100-acre plot. and it didn't have a road into it. So they put a road across all the lots on the north end of the lots. It just happens to be, but one of the stakes was in that road basically. And when they come in and they have to resurface it and drop additional rocks on it anyway, the guy that was doing the resurfacing caught the stake and ripped it out of the ground. So it's like, so anyway,
we found some stakes that were from like the olden times, and it was, the reference for it was 10 paces west of this oak tree that no longer exists. So, that kind of thing. Yeah.
Yep. Great accuracy. Yeah.
The official survey marks, the monuments as they're called, are published in the province of Ontario. And I identified 2 of them exactly, which are close to where I was going to run the contest, because I wanted to get some way of determining if my GPS devices were accurate. So I identified where those things are. You can still find them exactly. But then I realized that's all very nice, but it's not going to help me much based on what I'm learning about GPS systems. Mine are close enough. They will never pinpoint where a monument is.
It's grenades and bocce ball, I think.
Yeah. Well, guys, thanks very much for all the input. I appreciate it.
Oh, anyway, so the next door neighbor, he's, he could be on one of the, worst neighbor bulletin boards or whatever, or not bulletin boards, but, websites. Anyway, he thought, let's see, how is that? The neighbor on the other side didn't place his fence properly. So she paid for the surveying of all the lots down the road. And it turns out that the latest survey, the fence that I put up was not quite on what they're saying is the actual property line, but I think I don't know, it's a little to his side on the south end, a little to my side on the north end. I don't, we're not going to redo the fence. So
my former father-in-law had a large property that he wanted to split years ago. So he had to hire a surveyor to survey exactly where the boundary was going to be. So they came along and they did the surveying, and they found out that when he had built a big garage on the back half of his property, the front of the garage was on his property, the back of the garage was on the next property, and they made him cut the segment out of his garage.
They actually did? Really? Wow.
He couldn't sever until he did that.
So it's relevant to this discussion and to Mickey Dean's question about mounting a base station on the back of the truck. When I was working in Colorado, we had this issue of needing to establish exactly where certain points on our test ground were, and without bringing in a team of surveyors. And what we did is, if you go to the National Geodetic Survey site, you can pull up maps of where survey markers are, and they give you exact lat lons of the marker. Now, that said, it can be difficult to find the markers, and out of probably 4 or 5 that I searched for, I think I found one. One was actually embedded on the side of a bridge, like the bridge had a little edge, like to stop cars from falling off. And there was
And where did you find that data?
In there.
Where did you find the data?
I'm sorry, what?
Where did you find the data?
If you give me a little bit, I'll post a link to where you can find the map. But so what you do is you find one of these, you find a map with, there'll be 3 or 4 in a 10-mile radius. They're just everywhere. And so you find one that you can actually find, and then you sit your base station over the top of it, and then you go to some reference point on your site that you want to reference to. So, you know, for Mickey, that could be wherever he's got his mowers working, and that gives you an offset from that known point.
Yeah, and that's what I was doing when I was looking for reference points here. So, and I was only able to find 2 out of 5.
So it used to be that the RTK to go, they said this 20-kilometer rule. If it was within 20 kilometers, it was okay. But I thought, well, okay, now Steve's got one right on the place where we would need one or want one. But I thought those other locations were more than 20 kilometers away. Richardson and I think I forgot where the other one was. So that rule apparently doesn't apply or anymore, or do you get reduced accuracy on if it's more than 20 kilometers?
My understanding is it fades away more than drops off a cliff, but I have no concrete data to support that.
Just search on long baseline RTK and you'll find articles that some of them will do tests up to 50 kilometers and still get good results. But they do drop off.
Okay.
But a 50 kilometer correction that does come in, can still be way better than any other form of GPS signal.
And so to just share, exactly.
And about half cost, you don't have a base station.
So here's about where I live, and so this is I just pasted a link to the NGIS, one of the National Geodetic Survey maps. You can just put in a zip code or an address, and it'll give you all of these points are points that have been surveyed in. So if I wanted to go to, for example, close to me might be K947, and then you can go to the data sheet for that survey mark, and what it should give is so it gives you this is in NAD 83. You got to be careful about what your basis is, whether it's because generally these days people will use I forgot the name of the base. So you might have to offset. There might be an offset, but NAVD 88 isn't what most people use these days. But anyway, here's its position north and position west. So if you can then photographs, you can maybe well, that one doesn't have any photographs, but when I was looking around for some of them, I found some that did have photographs of exactly where they were.
So a NAVD 88, is that a kind of the equivalent to an an F9 or something, or what is that?
No, it's a WGS 84 is what is the basis for most navigation, and it defines as I understand it, the shape of the Earth and exactly where lat longs will end up on the Earth, and that's a different model than NAVD 88. Nope, I don't know. Sorry, I'm doing this on the fly, and I shouldn't. I haven't really looked around my area for survey marks and particularly tried to find them. Ah, here we go. So here's one over in Frisco. So yeah, that looks like that. So that'll be that little round thing in the base of whatever this pedestal is, will be the survey marker.
Kind of makes you wonder, though, how old those survey markers are and what equipment they use to establish its actual position. You know?
So yeah, and so they have this like embossed National U.S. Coast and Geodetic Survey benchmark. Gives you a number and a date for it. So yeah, that's what you want to find. And so that particular one was this triangle here at the Frisco Municipal Tank. So anyway, that's how you find.
So how did you drill into that data? Did you just click on it?
So I put the link in the chat, and if you click on that link, there's a search box, and I put in my zip code.
I did that.
What?
I did that. May I share?
Yeah.
Yeah, Paul, did you say that was the base of a water tower?
That's what it sounded like.
Oh, okay. Yeah, I was going to say, if it's a fenced-in area, don't get caught trespassing. They'll think you're a terrorist or something. You're going to poison the water supply.
Okay, so here's Des Moines, Iowa.
Yeah.
And I'm just south. I'm right in here. Can you see my cursor?
No.
Nope.
Yeah,
I don't think they show up.
If you click on one of the dots that's in the general area of where you live, it'll pop up that little pop-up box that tells you more about that survey marker. Oh, now I see your cursor.
Really? That's interesting because I actually switched tabs. Okay, so Carlisle, there's Carlisle. Oh, Indianola. Okay, this is where I want to put the base station. Okay.
Yeah, so click on that black dot.
Well, that's where I want to put it.
There you go. Okay, so then try clicking zoom to.
That's an address that I entered. So let's try one of these dots over here. And I'm not getting anything when I click on it.
Really? Huh. I don't know. All the ones I clicked on in my area produced that little pop-up box that you saw.
Okay, so I will work on that.
Try that triangle over to the left at Marion Cole.
Marion.
To the left of Indianola, there's Marion.
Oh, Martindale.
Oh, Martindale. Okay. Try clicking on the triangle. Nothing?
No.
Huh. I don't know.
No.
Huh.
You could see my cursor, I believe.
You'll have to research that. Sorry.
Mickey was suggesting zoom in, maybe.
Yeah, maybe. So I'm getting a pop-up.
There we go. Zoom in. That works.
Yeah. So then click on data sheet for more info. It should open up a new tab. So then if you click on the tab, I don't know if you shared the tab or shared your window, but
Okay, let's try this.
yeah, there you go. So
Okay,
so there you see
photographs.
NAD with, yeah, but the important thing is that NAD 83 position gives you 41 degrees, 22 minutes, 16 seconds north, 93 degrees, 20 minutes, 46 seconds west. And it says estimated accuracy of plus or minus 6 seconds. Yeah, and so those photographs should come up in a new tab as well. At least they did.
No
did for
image
me.
found.
Yeah, I found a bunch of them that had no images. So you just got to search around till you find one that does have an image, so you can find the survey marker.
Okay, but that's great. The key was to zoom in.
Okay.
Yeah, so you folks have answered a lot of my questions that I'm going to have 6 months from now.
That's why we're here. Stump the club questions. No, it's a
Now-
great discussion, guys. Great discussion.
Seeing as how I'm already talking. Okay, so I've been working on Raspberry Pi, Docker running ROS2, various versions. I want to run Jazzy, the latest. But today I tried to connect to an I2C device. I just cannot imagine there was any change from Pi 4 to Pi 5 for that stuff. I went on the kevsrobot.com, his I2C tutorial, and I could not connect. So I'll work on it. I'll get it figured out.
Well, welcome to the ROS group. There's a few of us in this club that use Run ROS.
Yes, and that's what I absolutely plan on using.
It's good stuff. Okay, do you want to unshare your screen? What else?
Thank you, guys. That was a great discussion.
So is everybody in the contest using GPS RTK?
Is what?
Paul, you were, right?
Yeah.
Yeah. And I'm assuming Scott was. I think he's got.
No, Scott was not.
Oh, he wasn't. Okay.
No. You and me were it.
Oh, okay. Yeah, I'm not certain I've gotten mine to work 100% in GPS mode, but the one of the things that they said is that on the rover, if it is receiving RCTM 3, it will blink the RTK LED, and it was, but yeah, I think I have to do some more tests to verify the accuracy and say, okay, is it down to 2 centimeters like it's supposed to be or not. So,
are you using an F9P?
nope, M8P-2. It's their SparkFun modules. But that was the -2 was supposedly a variant that you could make either a base station or a rover, and you can do in survey mode on on the base station with the -2 module. So, and that seems to work pretty good. That's another thing that's a little weird. They in the documentation on the SparkFun website, they say to set it 300 seconds, which is 5 minutes, and an accuracy of like, I think it's 1.5 meters, or it might actually be 2 meters. I forget which, but usually it goes down to about 1.5 meters. And, in the 300-second in survey time period. And okay, if the base station is only accurate to 1.5 meters, how can it, help a rover be 2 centimeters? It just doesn't seem to make sense to me.
Well, because it could be corrected in this way, that you don't know where your base station is, but you can know where your rover is relative to the base station within RTK accuracy. So you can know your XY offset from the base station within 2 centimeters, even though you don't know where the base station is, to within a meter and a half. And that works just fine. Yeah. If you're like doing a Robo Columbus type course, because all you care about is relative to the base station. You don't care about the absolute accuracy.
Okay. Yeah.
Well, you kind of do, because the cones were published with the pseudo absolute from a different source.
Correct.
So you still want to be somewhat close, but when you do what Paul did and you take your own equipment out there and measure, that completely goes away. And it doesn't matter, as long as your base station stays the same base station and it doesn't move and it's still working, then wherever you measure your cone your target being, you're gonna get right back there within those 2 centimeters, 2 to 3, whatever, depending on your signal quality.
So you're saying it's repeatable. It's not necessarily.
It's repeatable versus absolute.
Right. Yeah. Okay. Yeah, that makes sense. All right.
So you just need one good location on your property. If you don't really care, you use that as your local reference point, right? And you measure where your robot is at that point. It may be a little different from what Google Maps says.
Yeah.
But as long as you're comfortable with it and your base station is stable, you're going to be able to reach that spot and anywhere relative to that spot on your local operating zone. You'll be good.
Yep.
Just a word of experience. I did exactly what Kareem's describing, but when I first started doing it, some of the locations I wanted the robot to go to were, so I was translating it into UTM, Universal Transverse Mercator, which has northing and easting. So it's meters north of the equator and meters east of your local zone, whatever you're in. Well, my origin, some of the points I wanted the robot to go to were west or south. And when you get into a negative offset of your local origin and you try and figure out, should the robot be further north or south when it's negative from your reference, it just makes your brain go fuzzy. And so my experience was choose an origin for which everything is north and east.
Hmm.
So I picked my origin at Robo Columbus to be across the street from Steve's and in his neighbor's driveway up towards the main road, because it was like everything in Steve's yard was north and east of it.
Wondered what you were doing up there. It's kind of, why is he setting it up on the road like that?
You know, the neighbor probably was looking through his binoculars saying, "Who's this guy sitting with a laptop in my front yard?"
Some strange equipment, you know, tripods and everything.
Yeah. Hey, if we're done with this topic, I've got a question for you guys. During Black Friday sale, so Carl helped me see, and in the discussion last week, helped me understand why I need to have a brushless DC motor on the new robot, because I want full torque at very slow speeds, particularly a sensed brushless DC motor. But I was looking on Palulo, and they've got brushed motors and stepper motors, but no brushless motors. And I think I'd looked maybe on Adafruit as well and hadn't found any brushless DC motors with controllers. I know last week Kareem pointed me to Rev Robotics for a controller. Where do you guys go for your motors to try and find a motor and a controller that will go with it?
I go to my pack rat zone where I've accumulated motors from Tanner's.
Yeah, but not modern stuff. You wouldn't find this at Tanner's, I think, right? This is more modern brushless RC stuff.
Yeah.
Oh, RC, yeah, no.
And specifically what I'm trying to replace is this Titan 550 that's a brushed motor that came with the new robot kit. And so I need to, it's got a flat on one side of the shaft. So I need to find a motor that's this size so it fits in all the mounting and everything, but is brushless DC. Okay.
Yeah, probably RC hobby car type places.
Oh, okay. They'll sell that. Okay, great.
Yeah. But I just used brushed DC motors. I don't do the brushless just because it's simpler and cheaper.
Yeah, I thought the brushless motors were fairly common with all the hobby shops that, cater to that kind of business, right?
Yeah.
Yeah. So.
But yeah, if you go to like any of the robotics websites, most of their stuff is brushed.
Right.
Thanks for the link, Kareem. Is 550 a size?
Yes, it's a size. It's a, but in brushless, it means it. In other words, it's basically the same size as the 550s that we use as DC motors, right? In terms of the diameter of the case and the length of the thing, and but the power spectrum, I guess, is quite different. So I wouldn't call it a power capability necessarily, but yeah.
So this one that you posted the link to doesn't look like it's a censored motor.
That one may not be.
But I can go and look for a 550 motor that is on their site.
I don't think that they would have a censored one. What they do is they so when you talk about censored, like if you're talking about an encoder, there is a way to take one of their encoders and put it on the shaft, on the output shaft. So that would be a separate cost.
So Carl was talking last week about he'd done research on brushless DC motors that had Hall effect sensors built in, and the
Yeah,
Go
I
ahead.
mean, I'm lazy and space concerned, so I was just searching Google and Amazon, and it's easy to find them. Brushless sensored ED, and they come in 540 size, I guess, whatever that means. And there's a bunch of brands. I mean, they have a premium over brushed, but I
Okay.
didn't. You see some?
What's
oh yeah, okay. So Google did turn up a bunch of results on that.
Yeah.
Okay.
so why do you want coders on them?
Why
Because
do you
Opposed to
want
using
coders?
something like RTK to go.
I think that there's a very real advantage to getting a censored motor and using it with a controller that can read the Hall effect sensors, and it is that so 540 and 550 are nearly the same, Kareem?
Yeah, it's not
They are,
about
yeah.
Oh,
the
Mickey Dean.
sensor isn't so much about odometry, it's about controlling the motor.
Yeah, because you can take the speed loop, you get rid of needing to have a PID speed controller,
Yep.
because basically the ESC tries to achieve your requested input speed, and if it can't, the motor runs slower, but it doesn't fall out of phase or anything. It doesn't start cogging, and you get full torque at if you tried to use an encoder, okay, that can tell you how far it's gone for odometry purposes, but it doesn't tell you what the phase, it doesn't feed back into the speed controller so that the speed controller will slow down if the motor can't achieve the requested speed.
Okay. So like currently on my small robot, I'm using a PWM with that pulse wave modulator, a 9685. And so I can run into problems there. Is that what you're saying?
Well, no, I mean, all it means is that you have to wrap a speed loop around it. So you've got to have encoders on it. You've got to derive the speed and then put that into a PI or PID control loop that adjusts the PWM ratio going into your drivers, into your motor drivers, to try and get back to the desired speed. And
Okay, I thought that was automatic, but based on the PWM, but based on the pulses.
PWM just gives you a ratio of how long power is applied to the motor versus how long it's not applied to. In a zero load situation, a DC motor will run at a given speed, given by its kV rating times the PWM ratio. But if you put some load on the motor, then it will slow down. And
Okay,
I'm thinking about
right.
if the robot gets like into a rut, like I was watching some of the Robo Magellan videos, and they have curves. So it runs up against a curve and it has to, or kind of like when Scott's robot ran up against the sewer cover, it has to like jump over it somehow. So it stopped for a little bit. So then your PWM ramps up, your control loop ramps up the PWM to 100% maybe, so you get full power. It jumps off, then your control loop has to ramp the PWM back down to achieve your desired speed. And all I'm saying is, if you go with brushless DC, that problem goes away. Or
Steve, even
it
with
becomes
brush
embedded
motor,
inside the ESC.
like to be even more challenged, with this, if you have two copies of the same model of brushless motor, you can give them the same PWM and the same voltage, they'll turn at different speeds.
Oh,
So-
I already figured that one out.
So if you try
I
and drive
already adjusted
straight
for that.
without a gyro or a compass, I mean, you need encoders. So the reason why I was searching for one like this, I guess, except, yeah, that's a censored one. The reason I was searching for something like this is that I can put an encoder on the motor, and then since it's directly on the motor, that's before all the gears. So I'll have dozens or even hundreds of ticks per revolution of the wheel. So I'll have very accurate distance measurement, which lets me do some, for example, in our Robo Columbus, it would let me do some kind of gut check against, well, the wheels are spinning, but the GPS coordinate isn't changing, right? So you can do some kind of sensor comparisons and cross sanity checks.
Yeah.
Or just run without the GPS at all, right? I can run for so much distance, so many wheel revolutions before I start worrying about the orange cone. And that way I can ignore the orange vest and orange shoes that Ray likes to wear.
Yeah, I'd like to be able to do that part also.
Yeah. So
And an RTK robot is sort of like one end of a spectrum, right? For your outdoors, you're using a very specific technology. You may not need odometry as much in that circumstance, but there's other circumstances, like if you have an arm on a robot, you really need encoders, right? That, you know, so it's not just about the, yeah, it all depends on the kind of use case you're talking about.
Yeah, the use case I'm talking about is the Mobot. So
It's probably less important that you have great odometry and great speed control on something like that, since you already have a control loop around your GPS position. So yeah, maybe you don't need to worry
Right.
about it as much.
Yeah,
Whereas
but you probably do want good speed control because you want your robot going at a constant speed, uphill or downhill.
That's the other point. Yeah.
Well, if you got RTK, you still know what your ground speed is, right? It's just it's more about Paul's thing that, you know, you'll be able to tell when your motors are turning but you're not going anywhere.
Well, and if you're using differential drive, then you want both wheels going at the same speed.
That's true. Yeah.
And
But even
I
that
wanted-
can be your bearing of travel can, if you're
Yeah.
using RTK, it can, again, it can be done purely on the RTK. Like, you don't have to have balanced motors and stuff like that. I would still always recommend it. I you know, especially if you want to switch to a different environment, and the problem with RTK is it can go out. You could be under a tree, you could be near a building, and then all of a sudden it goes real fuzzy on you.
yeah, see, that's really good to know. And so you said that's why I recommend that. What are you recommending? The encoders?
Encoders are like, I haven't produced a robot without encoders for 15 years, something like that. I would always put encoders on motors.
but
It's just like a standard practice, I would say.
yeah, it's a given for the kinds that we usually do, that there's an encoder of some kind somewhere of some accuracy. And the only thing that was what caught my eye and I think sparked Paul's interest in this particular discussion, was that with the particular implementation that was at Ray, someone just put an example of up a moment ago. Instead of having to get a motor here and an encoder there and slap it on the shaft and blah, 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 blah. What was nice about this option Paul and I are exploring is that the motor has the sensors built in. So it's got connectors for the motor windings, and it's got connectors for the Hall effect sensors, and it's all neatly fits inside the one case, and it hooks up with whether you use an off-the-shelf RC speed controller or like the kind that Kareem showed last week from, was it Vex Robotics or somebody, and these things they know how to read those motors with encoders, And not only do they give you speed and motor control, but the fancier ones, I think, Kareem, you were saying, give you odometer. They measure torque for you and odometer.
Yeah.
And so
Not
you can
just measure torque. I mean, you can do torque-based control.
torque control, and you can tell if your motor's stalled so you don't burn things out, and all kinds
Yeah,
of fancy
Kareem,
things.
you're talking about the ones that measure current in 2 phases, and it's like true FOC,
Mm-hmm.
field orientated control. I
Yeah,
think.
but it's not just the field oriented control. It's supplemented with encoders. So
Okay. Yeah.
so it's amazing what you get when you roll it all together, and it's got a professional solution, chipset solution behind it. Is pretty amazing. I think TI has one of the best videos out there, if I remember, on field oriented control. But that all this technology is like becoming so almost I wouldn't say ubiquitous, but it's much more. It's still more expensive than brush DC by a long shot, but it's getting more and more approachable all the time.
All right, so the link that was posted, did that motor include the encoders?
No, not the 551 that I posted. I'm not saying Rev is the best price. I haven't tried to compare them against what's available on Amazon. It's just a completely integrated solution that I know and we have experience with.
Or
That's not a motor with encoders in it. Whereas Carl shared a page with motor maybe and with encoders in it, and you can Google. I just Googled brushless censored motor 550 and got a bunch of hits for motors that I think some of them have encoders.
Yeah, that's one right there, right? It says censored. I've seen the Rocket brand a lot. And in fact, if you look at the end, you see 2 connectors. So I wonder if that's one of the, it says dual sensor port, convenient to wire.
Hey, can you paste a link to that in the chat, Carl?
It's actually, it's me, Ray.
Oh, Ray, sorry.
That's okay.
Yeah, so Ray, zoom in towards the back end of that photo if you could.
It's got a URL 2 miles long.
Well, take it all the way up to the question mark. Get rid of the parameter.
Right.
Okay. Oh, all right.
So, so you see all the way, it says DP, then blah, 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 then /ref. So take it just before this JPZ all the way to the left.
Right there.
Yeah, that works too. Yeah. Left of the question mark.
Okay. Okay. Oh, so you wanted me to zoom in on that?
Yeah.
Yeah. I'm assuming usually the Hall effects have, 3 wires plus power and ground. So 5.
But these are 3-phase, right? I think these have 3 halls in there. And I think if I remember reading just a week or 2 ago, I'll bet that's what that purple bump is on the back. But from what I've been reading, you see how one connector feeds out straight to the right. The other one comes up towards the top. And I believe they sell these because in different models, your wiring might want to go in different directions. And from what I've read, each of those pins, I mean, it's the same electrical pin. You can just use whichever connector you want.
Oh,
so
okay.
The first thought that came to my mind was that until Kareem told me I could get this super duper high-end controller that measures torque and washes your windows and everything, I was thinking that I would use a regular old boring censored RC controller that doesn't have that fancy stuff. And then I would I would use the second connector without having to have a splitter cable. I would use the second connector and run that off to a whatever controller board, Arduino or whatever, and count encoder ticks without having to hack into the controller.
Yep.
But I mean, now that we know that there's a CAN bus controller from Rev that does torque, and you only need one. I mean, it simplifies the wiring. It does all the fancy measurements. Lets you
Yep.
focus on beating Ray and Scott and Paul. And
But it is kind of expensive,
the price adds up.
per motor. Yeah.
Oops. Okay.
But we're not in a cheap hobby, I guess. Or we don't have to be.
We try to be
and
cheap
as
about
many
it.
hobbies, you can spend as much as you want, right? So
Yeah.
Okay.
we don't have anybody that's bought a dog though yet. The Boston Dynamics
Hmm.
Oh, yeah. Spot.
spot. Yeah.
Yep.
There's some knockoffs that are starting to get pretty approachable in price. So
See?
yeah. Almost. I mean, I'm not ready to drop 3,000 on a robot for a
No.
yeah.
Play dog.
Yeah.
Ray brought up an interesting question about why there are 6 pins, because you'd think you'd only need power, ground, and 3 outputs, one
Mhm.
from each of the 3 Hall effects.
All sensors, yeah. I don't know. I don't even know if that website I got out of it, but hopefully there's at least something that tells you what those pins were on the web page.
Somewhere. That was starting to smell like work though, so I blew it off. Ran out of time.
Yep. Yeah, well, actually the 2 biggest 3-phase brushless motors that I got were from when I worked at Hitachi. But there were 2 other sets that I got from Tanner's. And so it's kind of the very smallest one, just has an encoder on the back, no Hall sensors. The middle one has Hall sensors and an encoder, and the biggest one also has Hall sensors and encoders. So it, yeah, as far as what you get, I'm sure they're all custom, and you can pretty much order what you want from Elcom or some of those guys that make those kind of motors. But I'm sure the price at Tanner's was a whole lot less than what you pay for it for a custom motor, But even those, I think it's a different application than the RC motors. I think the RC motors are going to spin a whole lot faster, and so.
Well, that's where what the chat GPT talk that or question session that Carl shared a link to last week was so helpful, because it explained a lot of the terms that I wasn't familiar with, like how the number of poles and the number of turns per pole affect torque and speed. So I was like, oh wow, I didn't know that. That's pretty interesting.
I'll send it. I'll put it in the chat again here, because it was a handy discussion.
It really was.
I mean, whether you believe it all or not, it was plenty good enough to go do research on and ground truth.
So I'm assuming the larger number of poles, the slower it can rotate and the stronger the torque is, because you're
Correct.
Yeah.
But it also equally reduces the top speed.
Okay. Yeah. I kind of wonder if it's like a stepper motor in that regard, because steppers you can't really run at higher speeds. They're more for low speeds and holding torque and that kind of stuff.
Yeah. A 3-phase brushless is just a 3-pole stepper instead of steppers are always 2. Well, not pole's the wrong word. I don't know the right word, but in in steppers you have 2 phases. In brushless motors you have 3 phases, but otherwise they're identical.
But they're real handy for applications like the like this gimbal for holding a phone, right? Because I mean, this one has 1, 2, 3. It's a 3-axis. Each one of those is a brushless motor, and it must have some kind of sensor because it can maintain orientation no matter how you move around. And it has enough. I mean, the motors, they definitely get warm when you cantilever the weight of the phone off on some crazy angle. They really do, and they drain the battery quickly. But they have a lot of torque, and with all those poles, they have a lot of good control over position.
Yep.
Between the poles and the whatever they use for encoders. So they call them gimbal motors for a reason. Yeah.
Yeah, apparently that 6-pin connector is pretty standard. I'm seeing other motors with that same connector, and I haven't found a data sheet that explains it.
And that's kind of another thing that attracted me to it, because I know we're all a lot of us are comfortable with scratch built custom things, but I mean, I'm running out of time, so it's really nice to use standard off the shelf stuff. And then if you want to do custom, if you use the standard, you got options. If something breaks, it's easier to get a replacement.
The hoverboard motors actually had 6 wires in them, and the 6th wire was like a tack output, like an analog tachometer. The voltage varied with the speed of the motor.
Oh,
I don't know if that's universal, but and the hoverboard motors just had Hall effect outputs. They didn't have. There's no encoder on them. So,
but the
maybe
Hall effect needs at least 3 wires, power, ground, and the output of the Hall effect sensor.
right. Yeah, so that'd be 5, and then the 6th one would be, at least on hoverboard motors,
okay.
it's like a tack output.
Okay. Interesting. Well, are we running out of energy? Do we have any other topics for discussion? We seem to have beaten this one to death. If not, we might call it a night. Going once, going twice. All right. Good night, gentlemen. Good
Nice
discussion.
talking.
Thank you.
See you next week. Bye.
Good night, all.
Good night.
Night.